Hello and welcome back for lesson 2.1. In this chapter, we're going to be looking at frequency distributions and graphs. And the first lesson here is all about organizing data. So we're going to learn about a frequency distribution for categorical data, which would be qualitative, and then a grouped frequency distribution and how to read one. So a frequency is the number of times a value of that data occurs. A relative frequency is the ratio, it can be in a fraction form or a proportion, of the number of times a value of the data occurs in the set of all outcomes to the total number of outcomes. So it's usually written as X over N, or count over total. Okay. So this first example is in your virtual book or hard book if you have one, on page 52. It says it surveyed people and asked them to what their trust in the internet information. So A is they trust in all that they read. M is they trust in most of what they read. H is they trust in about 1/2 of what they read. And S was they trust in a small portion of what they read. So I labeled A, M, H, and S. And I went through and made my tallies. And then there were, for instance, on H, there were 1, 2, 3, 4. And then the fifth one you cross over, so they're in groups of 5, and then 6. So after I made my tallies, this one came out to be 4 in the A. There were 28 M's, 6 H's, and 2 S's. And if I tally this up, it comes out to be 40, which in the problem, they did state that there were 40 that took the survey. And so the percent is also the relative frequency. And so that is taking 4, which is your X. So in my formula, my fraction up here, X over N. So X, and then N is our 40. So 4 out of the 40 would be 0.10 or 10%. 28 out of the 40 would be 0.7 or 70%. 6 out of the 40 would be 0.15 or 15%. And 2 out of the 40 would be 0.05 or 5%. And then you always want to add your percentages to make sure that they add to 100%. Otherwise, you don't have all your data included. Okay. The next page, I gave you a table. It says the data below represents the amount in inches of annual rainfall in a sample of towns. So we have it's actually in groups here. And then this column is the frequency, so the X. This is the relative frequency, which should be X divided by N. And we can see N is our total down here, 50. And then our cumulative frequency is where you're adding up the frequency as you go. So this first one is just the first value, which is the cumulative frequency of 6. And then the second one would be the 6, and then the additional of the next group, which would be 6 plus 7 or 13. And then the next one would be 13 plus the next individual group of 15. So 13 plus 15 is 28. And so on. So we have 36. It's cumulative, so it's including every group from below, every class from below. So 13 plus 9 is 45 and 50. So the very last cumulative should be equal to your N. These should match. Then my cumulative relative frequency is similar in that it's accumulating the relative frequency column. So we start with the original relative frequency of 0.12, and then we add the next one. And then you can see where those are just keep adding, and then those should equal 1 or 100%. So A says, find the percentage of rainfall that is less than 9.01. So I went to 9.01, and that would be these top three classes. And it said percentage. So that means the relative frequency is a percentage in decimal form. So that would be the percentage that is less than 9.0. So it'd be all three of them together. So I can use the cumulative, which is 0.56. And so that's 56%. B says, find the percentage of rainfall that is between 6.99 and 13.05. So 6.99 is this class here, all the way through 13.05. So it's these three classes together. So I could either add their relative frequencies, 0.3 plus 0.16 plus 0.18, and I should get 0.64 or 64%. And then letter C says, find the number of towns. So it's the number. I'm not looking for a percentage this time. Find the number of towns that have rainfall between 2.95 and 9.01. So 2.95 and 9.01 are all for the first four classes. And we want their frequencies total because I just want count. So that would be 6 plus 7 plus 15 plus 8 is 28 towns. Okay. So my official example one says 19 people were asked how many miles, they commute to work each day. The data are as follows. I have them listed there. And then we have this table here. So here is the data, possible values from 3 miles all the way up through 20. Now notice that there's no 6, and that's because that those that were in the 19 people, nobody answered 6 miles. We have the frequency, which is your X, the relative frequency, which is X divided by N. N is 19 because there were 19 people that were asked. And then our cumulative relative. And it says, is the table correct? If it is not, correct, and what is wrong? So I'm going to point out some things here just so you, in case you don't see them, you're new to this. One thing we would look at, I would actually go through the data and tally that up. And the first thing I would see is there are 2 observations for 2, and 2 is not even on my data list. So we would have to add 2 here and 2 because there's 2 of them. And then we would have to do that relative frequency of 2 divided by 19, which is 0.105. So that's one error. It's kind of a big one. Also, there's only one of the 3s. So that changes the frequency and the relative frequency. If you go down to the data point 10, it says there's only 3 of those, but when they did the relative frequency, they did it out of 4 out of 19, but it should be 3 out of 19. And down here under 18, there's actually 2 of those. And so the relative frequency should be 2. And so the cumulative relative frequency, we're just going to correct that. And that should be 2 out of 19. Then this would be 3 out of 19. 4 out of 19. 7 out of 19. 9. 12. 14 out of 19. 15 out of 19, 16 out of 19, and so on. So there's a lot of fixing to do. So we did that. So B says true or false, 3% of the people surveyed commute 3 miles. If the statement is not correct, what should it be? If the table is incorrect, make corrections. We did that. So that was false. The 3 miles, there was only one of them. And so that's 1 out of 19, which comes out to be 0.0525. C says, what fraction of the people surveyed commute 5 or 7 miles? 5 or 7, there were 3 and 2, so that looks like 5 out of the 19. D says, what fraction of the people surveyed commute 12 miles or more? So 12 or more would be 12, 13, 15, 18, and 20. And we have to count up the number of people. So that would be 2 plus 1 is 3, plus 1 is 4, 5, 6, 7. So 7 out of 19. The number that are less than 12 miles, so that would be everybody else. So that would be 19 minus 7 would be 12 out of 19 people were less than 12 miles. And then what about between 5 and 13? So not including 5 and 13. So they have to be between 5 and 13. So that would be 7, 10, and 12. That would be 2 plus 3 plus 2. So 7 out of 19. So we're getting good at reading these frequency distributions. Okay, example 2 says the table below contains the total number of fatal motor vehicle traffic crashes in the U.S. From the period of 1994 to 2011. So starting at 1994, there were 36,254 crashes in that year. And then it goes down to 2003, and then you go back up here. It resumes at the top of this third column for 2004 through 2011. Here are the number of crashes. So it looks like they were kind of increasing quite a bit to about 2005, and then they went down. They've been decreasing since then. So and then here is the total. So let's look at the question. Number 1 says, what is the frequency of deaths measured from 2000 through 2004? So if we add 2000 to 2004, that would be starting at 37,526 all the way through the very first row in the next column. And that comes out to be 190,800. Number 2 says, what percentage of deaths occurred after 2006? So everybody after 2006, which means 2007 and beyond, right? So 2007, all of these total number of crashes and beyond. So what percentage means we have to take that number, which comes out to be 162,523, and divide by the total of 653,783. And that comes out to be, when you round it, to be 24.9%. Number 3 says, what is the relative frequency of deaths that occurred in 2000 or before? So remember, relative frequency is the same as percentage in decimal form. 2000 or before. So that means we're going to go up here and we're going to start at 1994 and add up all the way through 2000. And I challenge you to do that yourself just to validate. So that comes out to be 260,056 divided by the total. And that decimal 0.3984, 39.8%. Number 4 says, what is the percentage of deaths that occurred in 2011? Two 2011 had 29,757. And if you divide that by the 653,783, that comes out to be 4.55%. And lastly, number 5 says, what is the cumulative relative frequency for 2006? And cumulative relative means everything up through 2006. So if we add those, we get 491, 259, and there's probably a couple different ways that you could get to this number. There is a couple different ways. And that comes out to be 0.751 or 75.1%. And then the last problem here is all constructing a group frequency distribution.